everyone, welcome to the video lecture series on Chemical Engineering Thermodynamics 1. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In this video lecture, we will talk about energy and their type, various types of energy such as internal energy, which is most important for first law of thermodynamics for closed system. Then we will talk about other types of energy such as potential energy and kinetic energy, and then we will finally talk about work. So in this lecture we will talk about energy and their types such as internal energy, kinetic energy and potential energy and work. So let us start with energy. Energy is a quantitative property that must be transferred to an object in order to perform work or heat. Energy may categorize such as a microscopic energy and macroscopic energy. Microscopic energy which depend on molecule level, where macroscopic energy which is depend on system level. So energy may categorize on basis of microscopic approach and macroscopic approach. Microscopic approach which means energy at molecule level, and macroscopic approach which means energy at system level. In microscopic energy further classify as internal energy, where macroscopic energy further classify as kinetic energy and potential energy. So we will discuss this all energy in this lecture. So let us start with internal energy. Internal energy is a microscopic energy. The energy stored in system by configuration and motion of molecule in system is called internal energy. It denoted by capital U. So energy stored in system due to the various motion of molecules such as translational motion, rotational motion and vibrational motion. So energy stored in system due to the various motion and configuration of molecule, then that type of energy is known as the internal energy. In this type energy we are considering motion of particular molecule. We are not considering motion of whole system. If we are going to considering motion of whole system, then that type of energy is known as the kinetic energy. But in this type of energy, in internal energy, we are considering motion of particular molecule in a system. If the temperature is high, then motion of molecule is high. That's why internal energy is high. So at high temperature, internal energy is high. At low temperature, motion of molecule is a low. In result, internal energy is also low. So at lower temperature, internal energy is a low. We cannot find absolute internal energy of particular system. So it is impossible to measure total internal energy of substance, and therefore absolute value of internal energy are not known. This is not a serious limitation, because absolute value that are usually need in thermodynamic analysis, we can only measure change in internal energy. Change in internal energy which means change in internal energy of state. Internal energy is a one type of state function, which means it's not depend on path take to reach final state from initial state. So this is all about internal energy. So let's talk about potential energy. Energy stored in system due to the some height or some elevation from reference plane, then that type of energy stored in system is known as a potential energy. Potential energy is a one type of macroscopic energy, which means potential energy is depend on whole system. To understand this, let's consider this figure. Let's consider this rock. This rock is some height or elevation from reference plane. So energy stored in system or energy stored in this rock is a potential energy. Potential energy that can be given by PE is equal to mgz, where m is a mass of system, g which means gravitational force, and z which means some height or elevation from reference plane. To understand this, let's consider one example. Let's consider this figure. In this figure, there is a book in hand of this person. This book is some height from reference plane. Height from reference plane, which is a 1.5 meter, and mass of this book that is 0.5 gram. So if we want to calculate potential energy of this book, then we have to apply the equation PE is equal to mgz, mass of this book that can be given by 0.5, gravitational force which is a 9.8, and some height or elevation from reference plane that can be given by 1.5. Multiplying this all term will get potential energy is equal to 7.35 joule. So energy stored in this book as a potential energy, and that energy is 7.35 joule. So let's talk about kinetic energy. Energy stored in system due to the motion of that system, then that type of energy is known as a kinetic energy. Kinetic energy is a one type of macroscopic energy, which means kinetic energy is depend on whole system level, where internal energy is a microscopic energy. Internal energy is due to the motion of internal molecule, where kinetic energy is a motion of whole system. So both are different energy. Kinetic energy is a macroscopic energy, where internal energy is the one type of microscopic energy. Internal energy is depend on motion of molecule, where kinetic energy is depend on motion of whole system. To understand this, let's consider this car. If this car is moving on some velocity, then this car has some kinetic energy. If the speed of car is high, which means kinetic energy of this car is high. If speed is low, then kinetic energy is also low. So if any object in high speed, which means kinetic energy of that object is high, speed of that object is low, which means energy of this object is also low. Kinetic energy of any system that can be given by Ke is equal to 1 by 2 mv square, where m is a mass of system and v, which means velocity of system. To understand this, let's take one example. Let's take a car which mass of 700 kg is moving with speed of 20 meter per second. Now if we want to calculate kinetic energy of this car, then can calculate using this equation. Ke is equal to 1 by 2 mv square. Mass of car which is 700 kg and speed of car which is 20 meter per second. Multiplying this all term will get Ke is equal to 1,40,000 joule, which means 140 kilojoule. So energy can measure in kilojoule or joule units. So let's talk about work. Energy is expanded in form of work when force act through a distance. To understand this, let's consider this figure. If applying some force to this box, then this box is moved toward in direction of force and take some distance. So can say that work is equal to force into distance. Force that can be given by capital F and distance that can be given by small l. If applying for small distance, then can say that dw is equal to F into dl. Consider this equation as a equation number 1. But force that can be given by F is equal to P into A. P which means pressure and A which means area. And distance that can be given by volume upon area. For small distance, can say that dl is equal to dv upon A. So using the both value of force and distance in equation 1, we'll get dw is equal to P into A into dv upon A. So A will be cancelled and we'll get final equation that can be given by dw is equal to P into dv. So a work is expanded in form of work when force act through a distance. So W that can be given by F into L, force into the distance. By deriving this equation, we will get final equation, which is a dW is equal to PdV. Work is a path function, so it's depend on how the change take place from state 1 to state 2. Unit of work that can be given by in joule. So this is all about the work. I am completing my lecture here. In this lecture, talk about various types of energy, such as internal energy, energy in system due to the configuration of molecule or motion of molecule, then that type of energy in system is known as the internal energy. Then talk about potential energy, energy in system due to the some reference plane or height from reference plane, then that type of energy in system is known as the potential energy. Then talk about kinetic energy, energy in system due to the motion of that system, then that type of energy is known as the kinetic energy. Then talk about the work. Kinetic energy and potential energy is a one type of macroscopic energy, where internal energy is a microscopic energy. So this is all about this lecture. I am completing my lecture here. Thank you.